brittleness, because now you're working with what actually happens in the network, maybe not what the theories of the network, and maybe not what other people think the network should be doing or will be doing next week. Actual observations always useful, but maybe not telling you gospel truth. And then there is also the very real fact that the existing model or theory of the internet may not fit today's realities. We've had, other panel sessions talking about what are the realities for things like mobile devices, and does the traditional model of the internet host really work when you've got a mobile handset as your primary mode of accessing the internet? And the answer there was complex, but certainly not entirely yes. So today I think we'll talk a lot about different perspectives on how to improve the user's internet experience from these different perspectives, both from the perspective of objective reality as well as a little bit from the notion of theory. So at this point, I would like the panelists to introduce themselves and say a little bit about their perspective on this particular topic. And if we could start with you, Pat.
Hi. Try that again. Hi. My name is Pat McManus. I work for Mozilla, and at Mozilla, I own the networking code, generally speaking, that goes into Firefox. So we have a point of view of, a large share of the number of users as they see the web portion, of the internet. So we all want to see, growth and innovation that we've been talking about. And to me, the two most important axes that we've got to follow here are responsiveness and security, right? Responsiveness is more than packet RTT, right? It's the responsiveness of the entire application and how all those protocols interact, and basically the time to get you the information you're looking for when you make some action through the UI. In security, I would make the argument that what's available on the internet is pretty decent. What's typically used is pretty awful. And the reasons for that have a lot to do with how all the various building blocks interact and the incentives that go with that. And so I think, there's work to be done there. So going forward, what we want is what somebody yesterday called the innovation without permission model, right? You want the edges of the network to be able to be able to innovate on these topics I just talked about, and to do that, you want to give them the right building blocks. And in our space, we've traditionally called those layers, right? IP, DNS, TCP, SSL. All that going forward. But what we've seen is a very literal use of those conceptual layers as implementation choices. And that has led to some less than optimal implementations that are catching up with us, and they're sort of the uncaptured opportunity that we have. So I invite you to think about the use case of downloading a little button, a 1 kilobyte image that says, I like this, or share this, or what has to happen for that to work. It's 2013, so you care about your users' privacy, so you're going to deploy that over SSL, right? So we'll get that out of the way. And it costs you to do this, at least one round trip of DNS, maybe more than that for DNSSEC. One round trip for the TCP establishment, probably 2 to get SSL going. And then, because SSL isn't really tightly bound to TCP's congestion control windows, probably another one to grow the congestion control window just to get your certificate down. And after all that's done, you can do one more round trip for your HTTP request and response. That's 7, 8 round trips by the time you're done. That's about a second, right, in order to get your one kilobyte image. It doesn't matter if you go upgrade your home broadband service from 2 megabits to 50, it will still take a second to transfer that image, right? And most of that is because of how the interactions of how we think about these things have come to play. So as an app developer, I ask, how do I get all those properties I want? The reliability, the in order, the congestion control, the security, these are all good stuff. I don't want to give up any of that stuff. But I'm just moving 1K of data, right? Why does it take me a second to do that? How do I get all those properties without all the bad interactions? And then how do you deploy that on an internet with middle boxes and firewalls and NATs and all those things that tend to dominate so many a good idea of a working draft going forward. And the straightforward answer is the results in coming up with things that we're seeing a lot more of, where you see all the layers squashed into one protocol, one layer of protocol, often tunneled over UDP. So BitTorrent, notorious for this. Google's new proposal with Quick, very similar sort of thought. And they achieve what are really promising results coming out of that. So I think the question for us as an internet community, right, is how do we redraw how we think about layers and processes and working groups and the other pieces of rigmarole we have, so that we can design more robust building blocks that people can reuse at the edges where they don't reinvent the entire wheel, right, and yet still don't suffer these kinds of penalties.
Great. Thank you. Jason?
Sure, thanks. So my name is Jason Livingood. I am from Comcast, which is a large ISP in the United States. And I like the topic at hand here, improving the internet experience, because that's mostly what my job is about. And so, I think there's been a lot of work globally to measure the internet, particularly lately from an end user perspective, which I think is really interesting. And doing that from an end user's perspective helps end users really understand what contributes to their experience and why it might be good or bad or problematic at certain times of day. And I think that that's had the benefit of sort of, improving everyone's performance in the ecosystem that's being measured. And, that obviously that's getting started to, in terms of a standards effort at the LMAP working group, which is nice. But Leslie, you earlier had a slide up that showed some aspects of performance. So it was throughput and latency and jitter. And I think in the past, most people really just focused, especially consumers, on throughput. So, speed, and that's all it is. And there's a lot more to your internet experience than just that. And, it's latency, it's security, it's a lot of other things, even reliability across the day. And one of the big ones there, I think, is latency. So I think on that topic, Jim Geddes and others have, really done a great job of highlighting the issue of buffer bloat and really trying to get the community focused on that as an issue that can really have a big impact on end user performance and, what the internet is like to the average user. And so I know there's lots of discussion here about different AQMs and where the, the future may be there. And, hopefully that leads to something good in the future. But I also think that increasingly end user performance or internet performance more generally is really strongly influenced by content providers or content CDNs and sort of what's happening at the edge, particularly to the extent that it's large file sizes and so on. And I think that maybe links a little bit to the notion that Leslie mentioned about sort of the elephant, and if you optimize just to your part of it, that can have unexpected effects on other parts of the ecosystem. And while it's good to have that loose coupling, that permissionless innovation, that's an obvious strength of the network. There are limits to it naturally at some point. What you're at certain points of scale. And in certain areas that you're trying to experiment in and try new things. So I think at some point, there may be things that we're trying to improve in the network that will require a greater degree of coordination among the different layers. And we've seen a little bit of that with all of the focus on IPv6 as an example. But in terms of other things that really impact performance, I think we'll start to see that more of that in the future. And I think that's probably all I've got at the moment, but I have lots to say once we get into Q&A.
Good. Go ahead, Stuart.
Thank you. My name's Stuart Cheshire. I've been working at Apple for more than 10 years now. And of course, we care a lot about user experience, like everybody here. One of the first things I did at Apple was what Apple called Bonjour, DNS-based service discovery, so that users didn't have to type in IP addresses. And then NAT became very common, and users couldn't get to their computer at home. So we did the NAT port mapping protocol that became PCP, so that your computer could make NAT mappings to make it reachable. And then power management became very much in the spotlight. People wanted to save energy, and people realized they couldn't connect to their Mac at home if it was asleep. So that led us to develop the sleep proxy that will wake up devices on demand. These are all elements of user experience as well as the straightforward throughput and responsiveness that people care about. Patrick talked about how network speeds have increased, and I had an experience with this. My father has had DSL in England for more than 10 years. I think he was the first person in his street to have DSL. And he hasn't upgraded the hardware because he didn't care. And in the end, BT came along and said, we're sick of supporting this old stuff. We'll upgrade your service for free. And he asked me if it had worked because he didn't notice any difference. And I measured it. 6 months ago, he was getting 2 megabits per second. Now he's getting 35 megabits per second. But the web pages still load at the same speed. Email is no different. And that really highlights that while faster throughput is good, cutting out these round trips are really what is going to make the user experience, the responsiveness, much better. And we talked about how different players in the ecosystem each work on making improvements in the parts they control. One example that comes to my mind is 802.11, that's gone from 1 megabit to 511 up to 300 megabits with 11n, and now up to gigabit speeds with 11AC. Wonderful improvements. One of the ways 11AC gets that performance is by batching multiple IP packets together into a single 802.11 frame on over the air. Well, TCP is based on the ACK clock to gate out packets at a nice smooth rate. And what happens when 11AC batches all those ACKs into one frame is they arrive in a burst. The host then sends out a burst of traffic, overflows the buffers, you get loss, you get timeouts, you get retransmission, and performance falls off a cliff, and you can be getting 1/10 of the performance. I'm not just picking on 802.11 here, we've seen similar things with LTE. So coordinating all these different improvements that are going on so that they don't conflict with each other is really challenging.
Thank you. So, I mean, you each presented a slightly different position, and I know that you don't all have exactly the same view, so let's see if we can tease that out a little bit more. Maybe if each of you could say something about if you could do one thing to improve internet experience, what would it be? Would it be, say, ensuring that there actually was fairness that worked across the network, or would that help, or is that still going to get caught up in the overall problem of too many round trips?
I think the biggest barrier we face to improving experience is all the middle boxes, and it's easy to say that. I'm not sure what we do about it. It's becoming increasingly difficult to make any changes to anything on the network because there will be some middle box out there that breaks it. And it might be only 0.9% of all users, but nobody wants to lose even 1% of their customer base and have those people pick up the telephone and call. In the last 10, 15 years, I've noticed we've moved from a very heterogeneous environment where people were using FTP and Telnet and lots of different protocols to everything that's really centered on the web. When I check stock quotes and weather forecasts and maps, everything is HTTP GETs. Even things that aren't a web browser in the traditional sense on my phone are using HTTP GET. So in one sense, everything seems like it's converging on one model. And if you're on a network that requires you to use an HTTP proxy, you can't use Telnet, you can't use SSH, you can't use Jabber, you can only use things that are HTTP based. So that's fairly depressing because everything is getting forced into this very narrow pipe what I find that's interesting is just when we feel like everything has been crammed into this box and the only thing that we have left is web browsing, we have things like WebSockets and WebRTC, which are web really in name only. They're really new application and transport protocols that happen to be implemented inside a web browser. So I find that interesting that just when we think we've got everything crammed into this box, it starts bursting out the sides and out the back, and it won't stay in the box. So I view that as an optimistic sign that there is still a hunger for more creative use of the network than merely HTTP GET and PUT.
So I can't disagree with that at all. But if I can pick only one thing, for the most important thing, I would actually probably focus on the lack of transport security in today's internet as an opportunity to really improve the experience for really the people, of the web. I'll tell you in Firefox, and I've got anecdotal evidence this is true across the web. We see about 20% of our traffic in some form of SSL. And to me, that's just frankly appalling. People say they don't really care. What I do doesn't need to be secret, right? It doesn't need to be private. And I always suggest the thought experiment of, go home at night and if, over your driveway or your garage, there was a big billboard with your browser history on it every day, every click of everything you saw, broadcasting that to your neighbors, how would you really feel about that, right? And I think that's largely a technological failure because of these things. I don't think it's a technological failure and it's a process failure. We've got, sort of appalling interactions with the PKI. We make the thing as hard as possible to do, don't get me wrong. But in terms of an opportunity, I think that's probably the biggest one.
Okay.
So picking one is difficult. On the thought about middle boxes, that certainly resonates with me because I do worry on some level that internet performance gets worse before it gets better over the next few years as IPv4 addresses run out and lots of LSNs start popping up and doing unexpected things. But the one thing that I would probably pick here is Wi-Fi networks. So I'm absolutely fascinated by the kind of questions that we get sometimes, or the things we observe customers talking about, which is, say, they've just upgraded to a 50 megabit per second tier, and they can't figure out why they're getting 3 megabits per second on Wi-Fi, and you start to realize that not only is range an issue because they're through a couple of walls or something like this, but they're still using their Wi-Fi access point that's 802.11b from 10 years ago, and they've never bothered upgrading it because it never stopped working. And so I think that there are millions and millions and millions of those sort of types of consumer electronics in people's houses that will take a long time to get upgraded, and it's a real long tail that has a big effect on what end users think of as the internet and their experience.
Yeah, I like to call that the lightning strike upgrade strategy.
Yeah, exactly.
I'm very fortunate not to have much lightning around my house. So it sounds like there's two things that are sort of competing with each other. One is the issue that we're talking about users, and users are sometimes have the greatest inertia in terms of this change when it comes to actually spending money and changing stuff in this network that they don't want to have to understand how it works. So you have a bunch of legacy deployments, not just with users, but legacy deployments in the network, and legacy expectations. I mean, NAT boxes are built. They are a retrospective technology. They will support known existing applications as opposed to all the possibilities of future applications. The other side of this particular tussle is, that change happens. Innovation happens. New, desires come along. 10 years ago, or maybe 15 now, I'm trying not to count, it was all about the web, and the big thing was how many pictures you had on your web page because that was really slow to download, and maybe you had shocking video. And now we're at a point where everybody's shoveling up video on their uplinks, at a faster rate than ever was normal to consume it a decade ago. And that has an implication in terms of, your experience of your home network and how networks are architected. So I guess part of the question is, are we doing it wrong? Are there ways that we should try to either get rid of some of the legacy systems or pave over them? I think, Stuart, your point that everything is over HTTP, whether or not it's the web, is really a mechanism for trying to sort of leap over some of the legacy systems. Is that a viable approach, or is that basically building on potentially crumbly foundations? Well, I know it's happening, so we can just sort of get over the question of whether or not it will happen. But from the perspective of if we want to see a future internet and future internet experience that really is as optimized along these objective measures as we think it could be, what are some of the things that are being done that may or may not play well together?
Right. So the ways people are routing around that problem right now are not, one, they do HTTP bindings to things you would think would have, RESTful HTTP bindings, and that could be good or bad depending on the application. But beyond that, they've looked for, the one true port, right, which right now is TCP 443. And you can put a lot of stuff through there. And we are sort of reinventing all the mucks on top of 443, right, that used to be done at the IP layer. I don't think anybody thinks that's good, but it's the place we're at right now.
So the flip side of that is that the more that you actually solve the problem by paving over it, the more you're actually taking on responsibility for the entire outcome. Whoever you are, whether you are the network operator or the software writer or the OS vendor, and it doesn't give you the opportunity really of shared infrastructure. The upside of shared infrastructure, which is, crowdsourcing in essence. So if we really are headed in that direction, and we can't disagree that we seem to be, what are the things that we can do to try to get back to actually having some notion of primitives? And if we had primitives, what might they be? And just because more people are coming in and sitting down on the floor by the door, there are chairs back here. Feel free to walk by. We're not going to be shy about this, because sitting in that corner is blocking the one subtle access to the back of the room, and you will be tripped over. Sorry, I did have a question in there. Maybe you remember it.
In terms of things we can do, I'll take this opportunity to give a little plug for some work that I've been collaborating on with Jana Iyengar called Minion. We'll be giving a presentation about that on Thursday in the transport area. And we've seen increasingly that attempts to extend TCP run up against deployment problems. You can't add TCP options because too many middle boxes drop the packets or strip the options. Even things like TCP selective ACK, which have been around for a long time, still cause problems today. There are middle boxes that rewrite the TCP sequence numbers. They apparently do this to improve security in some very nebulous and tenuous way, but they rewrite the sequence numbers without rewriting the sequence numbers in the selective acknowledgement, which turns the packet into nonsense which the receiver can't make any sense of. And there are still, without naming names, there are mainstream internet hardware vendors selling firewalls that do this rewrite even today and have no plans to fix them. And that's very frustrating. The Minion approach says, okay, fine, we can't add any options, we can't add IP options, we can't add TCP options, we can't use the urgent pointer, we can't do anything that strays outside of the most well-trodden path. So we will build everything inside the TCP connection using in-band data so that to the middle boxes it looks like standard TCP. And we can put some extra brains at the endpoints to be smarter about doing out-of-order delivery when there's packet loss, but without changing what the packets look like on the wire. That's one approach. The other approach is being taken by many, many people, and that is to basically throw in the towel on TCP altogether and say, forget it, we'll just use UDP. And that's the approach that's being used by Google Quick, among other things. And that also has a lot to be said for it, because I share people's frustration with trying to get anything done with TCP in today's world. The reason just building everything with UDP is not in itself a panacea is, well, there are many reasons. The main one in my mind is NAT gateways have to throw away connection state. They can't keep it forever. And TCP has a fin bit which tells you when the connection's over. So NAT gateways can generally rely on seeing the fin, and until they see the fin, they keep the connection live. So NAT gateways will typically have a lifetime of 30 minutes, an hour, 24 hours for a TCP connection. They'll typically have a lifetime of 30 seconds or 2 minutes for a UDP mapping. If we move all of our network communication from TCP onto UDP, so all the current stuff that we're doing with HTTP becomes layered over UDP, that makes that problem worse, not better. The NAT gateways have to be even more aggressive about throwing away state. So that's a challenge we have to tackle right now. Do we carry on down the path of trying to use TCP, or do we give up on it completely?
Anyone want to comment?
I love the minion work. Yeah, I think that's a good example of what I talked about sort of in my introductory remarks. You know, the way we've bundled things has led to these interactions that were impossible to perceive at the time it happened. So in the case of TCP, right, we've got this in-order reliable stream that also gives you, you know, connection management and congestion control and things you really want. But in the case of you know, an application protocol that doesn't want in-order delivery, right? You know, we'd like to do video, and perhaps we don't need all the data to be reliable, but you do want, you know, duplicates removed and good stuff like that. You don't want it in order. Now you've got to choose. Do you want to use TCP and pick up that stuff that introduces latency delays, or do you want to, you know, roll your own on top of UDP? And that's never really a very satisfying choice. So I think, you know, Minion is a great example of ways we can go forward. I also think you can look at some of the building blocks that have other notable bad interactions, and we can talk about new standards for how that can be done. So it gets tossed around, you know, SCTP and DTLS, right? They're really made for each other, and yet you establish one before you establish the other, and you get this strict serialization thing going on. So we can probably establish a building block that those two things smush together. But I think from a process point of view, we can talk about how we do that, or as an organization, in a better kind of way, whether it's providing templates instead of protocols, or whatever the case, you know, may necessarily be. So.
I guess the question is whether there's a single solution that would be workable both for your one case file solution as well as for a video, large-scale video, for instance. Because you might invest some negotiation up front for the video, but don't really want to do that many round trips for the 1K file.
Yeah, Google was in TCPM this morning with a really interesting discussion of when FEC is appropriate in a TCP concept. It's experimental work, and it's really kind of interesting, but they were making this distinction there in a similar kind of way that for really large video-like transfers, existing mechanisms to do error recovery work really well, and not in other situations. And so how do you build a protocol that handles those use cases? I think we can do it. I think it's also clear we don't have those things right now.
Right.
The one thing that I would just add is I think it's problematic if sort of everything, if the transport protocol becomes, everything's TCP/80 and TCP/443. I think you lose a lot of the benefits of layer separation and lots of other things. It's cool to hear a lot of the experimentation that's going on, and I think the sort of next question is, at what point and in what way does that experimentation go beyond sort of single entity, single organization experimentation much more widely, because it is such a diverse network that's complex and has widely varying access speeds at the edge. Being able to adequately test that out is, I think, going to be challenging, because you can't really simulate it, I don't think, really well, and it's such a varied network.
Well, a varied network at any moment in time, and a highly dynamic, because people's, as we discussed earlier, people's uses change significantly in ways that might have been predicted but hard to set up for.
I think one of the benefits we get in this community at the IETF is that the people who participate here have a good understanding of how variable the network it is, from links of a few kilobits to links up to megabits, short delays, long delays. I find a lot of people working on networking software today don't have the same kind of background that a lot of us have here. And I think one of our responsibilities at the transport area is to improve TCP, cut out some of these round trips, make it more responsive, make it better for low latency real-time data, because the longer we fail to do that, the more developers are pushed towards building their own thing with UDP. And it's kind of sad to me, if you put the clock back 30 years to 1983 and imagine that you're writing a network application, you look at the RFCs, your choices are UDP or TCP. And if you're a developer writing an application for iOS or Android or Windows Mobile today, and you get the developer documentation, your choices are TCP or UDP. And when you think what's happened in the computer industry in the last 30 years, think back to how our processors have changed: memory, storage, displays, punch cards. Punch cards have come a long way in the last 30 years. They're almost unrecognizable. The fact that we're still, now, TCP has had many implementation improvements. We've got better congestion control, and things have got a lot better in the implementation, but the service model it provides to the application is more or less unchanged over the last 30 years. And as more and more people move to UDP, I think we risk having problems from people building stuff that works in their limited testing and fails on the public internet. One of the interesting experiences I have at Apple every year is meeting developers at the Apple Worldwide Developer Conference. And I had a developer this year talk to me, and I won't name names to protect the guilty. They said, we need to turn on quality of service on the iPad to make it not lose packets. And I said, okay, I'm not a big fan of quality of service. So before we get into WMM APIs and things like that, let me understand the problem. And they had an application that sent video. And the way it sent video was it would take a still image 60 times a second, compress it with JPEG down to about 60 kilobytes, and then send that as one UDP packet broken into 42 IP fragments. And it would do this at a steady rate of 60 frames a second. And in the lab, connected to the computer over gigabit Ethernet, it worked perfectly well. On the iPad over Wi-Fi, they were getting roughly 97% packet loss. And they wanted to know the API to turn off the packet loss, because clearly the iPad could deliver 24 megabits over an 11 megabit wireless link. It was just choosing not to. And it made me wonder if when you write an iOS application and put it in the App Store, there are certain entitlements that you need to use certain OS features, and it really made me want to make UDP access an entitlement that you needed special permission for.
Well,
So-
one of the things, just real quick, that Stuart mentioned was sort of, advances, whether it's in transport or in TCP, other aspects of the network stack. And, I think it's great that, we as a community are working on that and trying to develop those things. And, you mentioned sort of a core, maybe router vendor or something like this that had an issue. But, we shouldn't underestimate the need to have at the edge software that automatically updates itself. And I think both of you, your respective jobs, have done a good job of making sure that when you have software updates, they get pushed out and those improvements are there. But there's also a huge amount of embedded stuff out there that probably, if you go into the local computer store today, some chunks of the software are 5+ years old and it will never be updated. And those are a problem. So I think one aspect of improving performance is knowing that we will always find these improvements. So people that are building gear, shipping software, should go in with the assumption that it will need to be updated, and it's probably best if someone doesn't have to actually take action, that it says, I have an update, or it does it automatically.
Great. And I'm happy to see that my mental telepathy has worked, because I was hoping to go to taking audience questions and comments at this point, and so thank you. Please go ahead.
Michael Wurzel, this goes back to what Stuart said about, for all these years we've always just had TCP and UDP. I think the root of this problem is that nobody's standardizing an updated API, because we are getting new services, right? We have, for instance, HTTP offering all these services. Are you going to write an application that bases itself on a complicated HTTP API when HTTP isn't always available, not always working? Okay, you could use the improved TCP with Minion. That has a lot of things in common with HTTP. Am I supposed to use TCP++, which is going to be Minion, or am I supposed to use HTTP with its own API? Am I supposed to make my application even more complicated? I think to break this whole thing, what we really need is to have a more generic API that just lets you pick a service. That's something underneath, use a different protocol. If that protocol is available, or would work under these circumstances, or otherwise use something like Minion. And the question is, who is going to standardize that? Because that's another debate.
Yep. Comments from the panel?
Yes, I agree 100%. The IETF have traditionally not defined APIs, and I think broadly that's a good thing in terms of specific function names and parameters. I think defining the conceptual service model is something that we ought to take on, and that's why I'm excited about the Minion work. And this is a challenge we have to take on, and I don't know yet what the outcome will be. It might be some combination that borrows good ideas from Minion, from Quick, from SCTP, but I think as a community we need to sort out something new rather than just the sockets byte stream model.
Thank you.
Dave Crocker, this is a fun panel because you're raising lots of really important, really hard questions that I think are largely being ignored in the IETF, and it's not that the individuals don't care, but I think the IETF isn't attending to these issues, and it would be great if this panel triggers some things to come out of that. To that end, first I'll suggest an item that I think was hinted at, but it warrants more attention. The reference to getting only 3 megabits over the Wi-Fi side hints at the diagnostic problems that we have in what I think we ought to start calling the combinatorial of things. We think in terms of IT departments, we need to think in terms of consumer markets, and the ops skills and the need for smooth operation is rather different there. The larger issue, though, for something that I think is actionable, although it'll be a treat making it happen, is the reference to various engineering parameters, latency, reliability, round trips, and so on. On the average, since I play mostly in app space, I will tell you on the average it's not only ignored, it's touted. I just came out of a session in which, although people would deny this, there was a certain amount of pride in adding round trips. I'm not kidding. They would deny it, but for those of us on the other side of the particular debate that was underway, that was the perception I have. But my point is that when we charter a working group, we don't ask the people chartering to do really much more than make some comments about functional efforts that they will make. And maybe a little bit about security, by which we usually mean a narrow set of issues and only are starting to pay attention to security, including perhaps privacy. So I'm thinking that we could get interesting if we try to press for charters to make some assertions, whatever they are, including we don't know, we're going to figure this out, along a set of parameters such as latency, jitter, whatever the set we think is a good one. And I thought the beginnings of that list that you were doing at the beginning of the session was really worth thinking about.
It's a good thought to take back to the IETF when we go back there.
Can we make a couple quick comments?
Sure.
Go ahead.
The one thing I was just going to say, and I thought, thank you for speaking at the mic. The one thing that triggered was thinking of the Wi-Fi portion of that. Today, when most people think about how to measure performance, they think about primarily sort of the access network portion and then increasingly in the house. But from an end user standpoint, they're trying to use application X.
Yep.
And, let's say that's an over-the-top video application. So not only do you have all the interplay of the in-home network and the access network and a middle mile network, but that application provider might use not just a content delivery network, but might use 3 or 4 of them. And in any given session, they're changing across several of them, and within a given CDN, changing from very local copies of files to very distant. And so understanding performance, for that user's experience changes second to second, and it's really hard to sort of take a snapshot of that over time, because by the time that they might report an issue and then you try to troubleshoot it, it's an hour later, or even it's 5 seconds later, it's entirely different. And I think that's a very interesting area. It's highly dynamic, an interesting area of performance to study.
Great. Pat?
So what came to my mind when Dave was talking was the best sort of institutional defense the IETF has with regards to sort of these layer interaction questions, and is our supposed adherence to working on standardizing existing efforts and running code, right? When you get real deployments of this stuff that's worked well in the wild, a lot of that stuff gets shaken out, whether or not it was on the initial requirements list or not. That is the official stance of the organization, but we all know in these working groups there's a lot of engineering by whiteboard committee going on, minting new technology instead of working on existing deployments and experiences. And I think maybe an emphasis in that direction of looking for more experience before going forward, and maybe rejecting some of the more speculative work that the IETF is doing until a later time might help with the problem.
Okay, thanks.
Jan Seedorf, is the mic on?
Yep.
Yeah, okay. I have a question with respect, or it's rather something I often wonder. A lot of friends are calling me lately. They're regular users, and they're doing video on they want to watch video on demand, and very often it's streamed. So they're having problems, when jitter comes up and the throughput is bursty. And at home, when we watch a video on demand, I either use iTunes or we use various streaming services. And sometimes when we use streaming services, this circle comes up and it waits for a second and my wife says, not again. And when you use iTunes, you see basically, 100 megabyte are downloaded. It'll take 10 minutes to download your 2 gigabyte movie, or I can start watching it even if I have bursty, bursts in the throughput. It's not going to be a problem. So I wonder, why is it so extremely popular I'm talking not about live streaming, for video on demand, why is it so popular to stream it? Is it the DRM in the browser that's hard to do? I mean, Apple did it in iTunes. Why is, for video on demand, streaming so popular?
I'm optimistic that that's going to improve. There's an extremely good research paper from Stanford a few months ago, and if anybody hasn't read it, I recommend it. It's called Confused, Timid, and Unstable. And it's describing TCP, or specifically the way TCP is used by these
what are
video
you saying? You're
streaming
saying
applications.
the streaming is getting better. What I'm saying is, for that use case or for that type of application, you don't need to stream, right? You can, basically you could, on what I have in iTunes, then it's a problem that the file always stays there and you need to delete it manually, but that's a different problem, right? Why not, for user experience? And again, a lot of friends are calling me and saying, why do I have this? And I said,
in my mind, the distinction between streaming and progressive download is a very small one and not very important one. I think the issue you're running into is that many of the current, and this is what the research paper is about, many of the current video streaming software implementations are just not very good. And one of the interesting things they found in the paper is whereas an iTunes download is just like an FTP download or an HTTP GET. The server sends data as fast as it can, and it's limited by the TCP congestion window, and it does the normal TCP sawtooth that the congestion window ramps up till there's a loss, and then it backs off, and it's continually probing, trying to go faster until it drives the network to overflow. Some of these video streaming things, because they don't want to do that, they attempt to measure the amount of bandwidth, and they found this very interesting anomaly, which is TCP always gives you a little bit less bandwidth than you ask for, because unless you're really asking for infinite bandwidth, if you're pushing as hard as you can, you drive the network to packet loss and you stabilize at what the rate is. If you're trying to send less than that, then some other flow will grow its share of the bandwidth until it forces a loss. And then you slow down, and they found these video streaming algorithms actually go into this death spiral where they start at 2 megabits and they get a loss. So then they step down to a lower quality video rate. And the other competing streams soak up all the excess bandwidth. So then they get another loss and they step down to half a megabit, and they end up stepping down through all the video rates until they get to the lowest quality rate. And I know the video streaming companies are now aware of this because of the paper, and they're working on being smarter about that.
I understand what you're saying.
So I just want to insert a logistical note, which is that I now have to close the mic because we've only got a few minutes left.
Okay.
So Olaf will be the last
Just one
question.
more comment and then I leave.
And I wanted to interject on that point. I think that there are some companies who I would believe understand streaming quite well, that do exhibit this kind of behavior. And I think some of it may be a different set of attempting to optimize. If they're providing, videos for free, for instance, they may have a problem where people wind up starting downloads of a multiplicity of things, and then maybe are there to actually watch it or maybe aren't. So their attempt to not deliver packets where they won't be wanted runs up against a timeout on your craptastic network, and all of a sudden you're in a world of hurt because they've made the assumption you're not actually watching. So I think that there are other layers of assumption.
I fully agree with that. My main point was just, even if you have the perfect streaming algorithm, a buffer of 8 seconds is just resilient only for 8 seconds of bursts. And why is that the main model we see? I don't understand.
I agree. 8 seconds is not enough.
Yeah. Olaf.
First, a clarifying question, and after that, I might be confused and ask some follow-up, but that might also be very confused. So first, a clarifying question. I believe that I heard in the beginning of the presentation, we could make this better if we have interaction with the lower layers, plural. Most of the presentation was about the knobs and dials that are available for TCP and improving those and getting a better service handle, so to speak. Did I hear that plural correctly? Might you want to go down several layers for reading knobs and reading dials and possibly even turn knobs at lower layers? Is that something that I just misheard, or is that something that is on the wish list? We didn't talk about it, that's for sure.
I suggested lower layers were interesting. It's not necessarily for the knobs, right? They already present very useful services and interfaces, right? But they exist as a layer with a set of preconditions. You do, if you want a secure connection, you do this SSL dance, which takes 2 round trips, maybe more, right, before you move any application layer data, right? And so the question is, do I need to do those 2 round trips to move my application data? At what point semantically is it safe to send? At what point is it semantically safe to receive? And can I move data into those unfilled packets, right? So that's the kind of integration we're talking about, not necessarily, not necessarily changing the services offered by those layers, because the layers themselves, are well thought out and stand the test of time, and that's why we want to use the properties they provide. What I would like to use them is in conjunction, in parallel with other layers and other services, right? And that's a big bottleneck.
Okay. That means I don't have any follow-up.
Okay, well, that's fortunate because we are at time. So thank you, everybody, for coming, and thank you, panelists, for spending your time with us.
Pointer on the paper. I hadn't heard that. That sounds fantastic.
Yeah, that's a good.
Yeah.
Oh. Do you want to? Yes.